We are starting with exercise 5 of quadratic equations. Okay. Question number 1. So they have given 1 plus m square into x square plus 2mcx plus c square minus a square equal to 0. So compare this with ax square plus bx plus c equal to 0. So a is 1 plus m square, 2mc is b, okay, 2mc is b, which is the coefficient of x, and c is c square minus a square. Okay, the values of a, b, and c by comparison. Okay, now they have said that the roots are equal. If the roots are equal, so b square minus 4ac is equal to 0, discriminant is 0. So b square is equal to 4ac. See guys, you can also find out alpha plus beta, alpha into beta, but then that will not be used anywhere. Okay, so b square, b is 2mc, 2mc the whole square is equal to 4a. A is 1 plus m square, and c is what? C square minus a square. Okay, so 4 m square c square, 4 1 plus m square c square minus a square. So this 4 and this 4 will get cancelled. Right hand side, I'll just simplify this or multiply the two brackets over there. So m square c square is equal to 1 c square minus a square plus m square c square minus a square. I have multiplied both the terms on the right hand side. Okay. So once doing that, m square c square will be c square minus a square plus m square c square minus m square a square. So m square c square, m square c square is getting cancelled on both the sides. Okay. Now these two are negative terms. In the proof, there are no negative terms. So take the negative terms on the left hand side. A square plus m square a square is equal to c square. Take a square common. 1 plus m square is equal to c square. Hence proved. This was question number 1. Question number 2. Okay. Question number 2, I'll just give you the hint. Since the roots are equal, b square minus 4ac is equal to 0. Put the values of a, b, and c. A is 4 minus m. B is 2m plus 4. Okay. And c is 8m plus 1. You put it in delta equal to 0. That is b square minus 4ac equal to 0. So b square is equal to 4ac. Put the values of a, b, and c. Simplify, you will get the values of m. Okay. Let's go to question number 3. So the quadratic equation is ax square plus ax plus b is equal to 0. Compare this with ax square plus bx plus c equal to 0. So a is a, b is 1, c is b, c is b. Okay. Now the roots of this quadratic equation. For this quadratic equation, the roots are real and unequal, sorry. So since they are real and unequal, b square minus 4ac is greater than 0. Had it been equal, then this will be equal to 0. But then they are unequal. So this is greater than 0. Okay. So b, that is 1. 1 square is 1. 4ab is greater than 0. So we got one condition over here. 1 minus 4ab is greater than 0. Now what we will do is they're asking you show that the roots of the other quadratic equation are imaginary. So they have given one more quadratic equation, x square plus 1 upon x is equal to 4 root ab. So we'll just simplify and get in a proper format. Okay, so x square minus 4 root ab into x plus 1 is equal to 0. So this is the other quadratic equation in a proper format of ax square plus bx plus c equal to 0. So a is equal to 1, b is equal to minus 4 root ab, and c is equal to 1. Okay, now we need to find out the nature of the roots over here. So we need to find out b square minus 4ac. B is minus 4 root ab. So square of this will be 4ab minus 4ac. A and c is 1. So this will be 4. Take 4 common. Okay, I think sorry, I just made a mistake. So this is 16 over here. 16 AB minus 4. Take 4 common. 4 AB minus 1. Okay. Now see guys, 1 minus 4 AB is greater than 0. So what will be 4 AB minus 1? Take all terms on the right hand side. Okay. Negative becomes positive and positive becomes negative. So the meaning of this is 4 AB. Okay. So it is 4. This is negative because 4AB minus 1 is lesser than 0, which we have proved over here. This is lesser than 0. Okay. So positive into negative is negative. Negative means lesser than 0. So delta, that is b square minus 4ac, that is the discriminant is lesser than 0. If the discriminant is lesser than 0, then the roots are imaginary. Okay. Let's go to question number 4. Let's go to question number 4. Ax square plus 2x plus 3a equal to 0. So a is equal to a, b is equal to 2, c is equal to 3a. Okay. Now sum of the roots is equal to their product. So let us sum of the roots be alpha plus beta, which is minus b by a, which is minus 2 by a. Alpha into beta is c by a, which is 3a by 2. Okay. Correct. So sum of the roots may be equal to the product of the roots. So minus 3a by, sorry, this is going to be minus, this will be 3a by a, which is 3. Now sum is equal to product. This is given condition in the problem. We are not assuming. It's a given condition. So minus 2 by a is equal to 3. So this implies a is equal to minus 2 by 3. Okay. This is your question number 4. Let us go to question number 5. Okay. If sum of the roots is m times their difference. So the quadratic equation is x square minus px plus q is equal to 0. So ax square plus bx plus c equal to 0. So a is equal to 1, b is equal to minus p, and c is equal to q. They have given sum of the roots is m times its difference. So first we'll calculate alpha plus beta, which is minus b by a. So that is p, and alpha into beta is c by a, which is q. And one more condition is given. Sum of the roots is equal to m times their difference. M into alpha minus beta. Now alpha plus beta is p, m times alpha minus beta. Okay. Now we have arrived at this particular point. Now see, we don't have alpha minus beta in the problem, right? We cannot really find it out. But then if you look at the proof, there are many squares over there. Okay. Always take a look on the thing which we are supposed to prove. So there are so many squares over there. So squaring both the sides. So p square is equal to m square alpha minus beta the whole square. So p square is equal to m square alpha square plus beta square minus 2 alpha beta. Okay, so this we already know. Now in the previous session also, alpha square plus beta square. Alpha square plus beta square is alpha plus beta the whole square minus 2 alpha beta. Minus 2 alpha beta, and this is also minus 2 alpha beta. Okay, so p square is equal to m square alpha plus beta the whole square minus 4 alpha beta. Okay, see guys, alpha square plus beta square is alpha plus beta the whole square minus 2 alpha beta. Then you combine this to get minus 4 alpha beta. Now you are supposed to put the values of alpha plus beta and alpha beta which we have calculated. So p square is equal to m square alpha plus beta. Now alpha plus beta is p, which we have calculated, and alpha beta is q. Okay, alpha plus beta is p, right? P square. So m square into p square minus 4q. M square into p square minus 4q. Okay. Now see, multiply this right hand side. 4m square cube. Now we require m square minus 1, and that this term should be a singular term. Okay, so this is a singular term. So 4m square q is equal to m square p square minus p square. So 4m square q is equal to, okay, take p square common over here, p square m square minus 1. Okay, so this is how we prove. We should always take a look at whatever we are supposed to find out. Fine. Let's go to question number 7. Let's go to question number 7. Okay. Find the value of a for which one root of the quadratic equation is twice as large as the other. I think I missed out the sixth one. Sorry. Question number 6. If one root of the equation is 4, while the other quadratic equation has equal roots, find b. So there are two quadratic equations given to you. So quadratic equation number 1. So the first quadratic equation is x square plus ax plus 8 is equal to 0. So one of the root of this quadratic equation is 4. Root of this quadratic equation means the value of x. So put x is equal to 4 in this. One of the root is 4, so put x is equal to 4. So 4 square a into 4 plus 8 is equal to 0. So 4a plus 16 plus 8, that is 24, is equal to 0. When you solve this, a is equal to minus 6. Okay. Now see guys, let's go to the next quadratic equation given in the problem. But remember, a is minus 6. So quadratic equation number 2 is x square plus ax plus b is equal to 0. Put the value of a. A is minus 6. Okay. Now what information is given about this quadratic equation is this particular quadratic equation has equal roots. Okay. So we'll find out a, b and c for this. This a, b and c are different. Huh? A is 1, b is 6, minus 6, and c is b. Okay. C is b. So here the roots are equal. So b square minus 4ac is equal to 0 because the roots are equal. So b square is equal to 4ac. Now b is minus 6. So minus 6 square is 36. 4a is 1 and b is c is b. A is 1 and c is b. So b is equal to 9. Okay. Yeah. Let's go to question number 7. Let's go to question number 7. Okay. So find the value of a for which one of the root of the quadratic equation is twice as large as the other. So the quadratic equation over here is a square minus 5a plus 3d into x square minus, sorry, plus 3a minus 1 into x plus 2 equal to 0. Okay. So a, compare it with ax square plus bx plus c. So a is a square minus 5 plus 3. B is 3a minus 1. C is equal to 2. Okay. Now alpha plus beta is minus b by a. So minus of 3a minus 1 upon a square minus 5a plus 3. Alpha into beta is c by a, 2 upon a square minus 5a plus 3. Okay. So these two things we already have. Now what they have given, alpha is equal to twice beta. Okay. Alpha is equal to twice beta they have given. Right. Now see, alpha plus beta is equal to minus b upon a. This we have already written. Now alpha is equal to twice beta. So 3 beta is equal to minus 3a minus 1 upon a square minus 5 plus 3. So beta is equal to minus 3a minus 1, 3 into a square minus 5 plus 3. So we got the value of beta. Now alpha into beta is 2 upon a square minus 5 plus 3. Now alpha is 2 beta into beta is equal to 2 upon a square minus 5 plus 3. Okay, 2 will get cancelled. So this is the value of beta square, 1 upon a square minus 5 square plus 3. Now beta we have, this is the value of beta. So square of this, so this negative sign, this particular negative sign will go, it will be positive. Okay, then 3a minus 1 the whole square upon 9, down also it will be square, equal to 1 upon right hand side over here will remain the same, a square minus 5 plus 3. What I did, I just put the value of beta over here. Okay, now see guys, one term will get cancelled over here from both the sides. So this part you send it on the right hand side. So 3a minus 1 the whole square is equal to 9 into a square minus 5 plus 3. Okay, I'll just go back to the previous slide. See, this particular term I have cross multiplied on the right hand side. Okay, simplify this, you'll get the answer of A. For this, you need to open the brackets, simplify, and then definitely you'll get the value of A. Okay, that I'll leave it up to you. Question number 8. Question number 8. So the quadratic equation given is x square minus bx plus c equal to 0. So A is 1, B is minus B, C is C. Comparing it with ax square plus bx plus c equal to 0. Okay. So if the roots are two consecutive integers, so alpha is equal to beta plus 1, or you can also write beta is equal to alpha plus 1 because they are one after the other, consecutive integers. Okay. Now alpha plus beta is minus b by a. Okay. Now alpha is beta plus 1 plus beta. Now b is minus b, so minus of minus b is b, a is 1. Okay. So this value is b. So 2b or 2 beta plus 1 is equal to b. Okay. So 2 beta is equal to b minus 1. So beta is equal to b minus 1 by 2. Okay. This is the first condition that we have got. Now alpha into beta is equal to c by a. Now alpha is beta plus 1. Put the value of alpha is beta plus 1 into beta is equal to c. C is c and a is 1. Okay. So beta plus 1 into beta. Now put the value of beta over here. Put the value of beta over here. B minus 1 upon 2 plus 1 into, put the value of beta over here also. B minus 1 upon 2 equal to C. Okay. So now what we are supposed to do is, in this particular bracket, we are going to take LCM. So this is B minus 1 plus 2 upon 2. And down it is B minus 1 upon 2 equal to C. Okay. Right. So now minus 1 plus 2 is plus 1. So this is b plus 1 upon 2 into b minus 1 upon 2 equal to c. So a plus b into a minus b is a square minus b square. Okay. So b square minus 1 is equal to 4c, and hence b square minus 4c equal to 1. This is what is asked. Find the value of b square minus 4c. Okay. This was question number 8. Let us go to question number 9. Let us go to question number 9. Yeah. So px square minus 2p plus 2 into x plus 3p equal to 0. So a is equal to p, b is equal to minus 2p plus 2, c is equal to 3p. Okay. So we are going to find out the value of alpha plus beta and alpha into beta. Okay. So alpha plus beta is minus b by a. Okay. So just a second. First, we'll write down the condition which is given in the problem alpha minus beta is equal to 2. It's similar to the previous problem. Alpha is equal to beta plus 2. Okay. Now we'll write down alpha plus beta. Alpha plus beta is minus b by a. Now alpha is equal to beta plus 2, which we have written in the previous slide. Okay. Alpha is equal to beta plus 2. Now minus b by a. So b is already negative. So minus b will be positive. So 2p plus 2 upon a. A is p. So 2p plus 2 upon p. So twice beta plus 2 is equal to 2p plus 2 upon p. Take 2 common over here. Beta plus 1 is equal to 2p plus 2 upon p. Okay. Now 2 will get cancelled. We will get the value of beta. Beta is equal to p plus 2 upon p minus 1. So beta is equal to p plus 2 minus p upon p. So here we are getting beta as 2 by p. Okay. We got the value of beta as 2 by p. Now there is one more condition, that is alpha into beta. Alpha into beta is c by a. Now alpha is beta minus 2, sorry, beta plus 2. Okay. We have written alpha is equal to beta plus 2. And at the same time, beta will remain beta. Now put the value of beta 2 upon p. Okay. And this is 2 upon p. C and a values we'll just put from the main question. C is 3p and A is p. So 3p upon p, which is 3. This is equivalent to 3. Okay. So 2 plus 2p upon p into 2p is equal to 3. Okay. So 4 plus 4p square, 4p, 4 plus 4p upon p square equal to 3. Just a second. 4 plus 4p upon p square is equal to 3. Yeah. So 4 plus 4p is equal to 3p square. So 3p square minus 4p minus 4 is equal to 0. Okay. So we have to factorize this. So it is 3 into minus 4, that is minus 12. So minus 6 plus 2 in between. 3p square minus 6p plus 2p minus 4 is equal to 0. Take 3p common, p minus 2. 2p minus 2 is equal to 0. 3p plus 2, p minus 2 is equal to 0. So p is equal to minus 2 plus 3, or p is equal to 2. So we got two different values of p. Now case 1, p is equal to minus 2 by 3. Beta is equal to 2 by p, which we already have. Beta is equal to 2 by p, right? Okay. So we'll calculate the value of beta now. 2 by minus 2 by 3. So 2 cancel. 3 goes up. So this is minus 3. Okay. Alpha is equal to beta plus 2. So minus 3 plus 2, which is equal to minus 1. Right? So this is case 1. Case 2, you can do it on your own in the similar way by taking the value of P as 2. Let me check. Yeah, P is 2. So you can solve the second case on your own. Okay. Yeah. Now question number 10 is actually from the previous exercise, similar to it. Okay. The new roots are P and Q, right? So P is alpha plus 1 upon beta and Q is beta plus 1 upon alpha. So we should do P plus Q and P into Q and solve this further. Relatively a very simple problem. Let's go to question number 11. Question number 11. So Px square minus 2p plus 3 into x minus p plus 1 is equal to 0. Okay. One root is 3. Since one root is 3, so you put x equal to 3 in this quadratic equation. Since one root is 3, put x equal to 3 in this quadratic equation. P into 3 square, 2p plus 3 into 3 minus p plus 1 is equal to 0. So 9p minus 6p minus 9 minus p minus 1 equal to 0. Okay, so this is 3 minus 1, that is 2. Okay, so 2p minus 10 is equal to 0, so p is equal to 5. Now once you get the value of p as 5, once you get the value of p as 5, okay, you are supposed to put this value of p in the quadratic equation back. So here, here and here, and solve this quadratic equation, you will get the other root also. Okay, yeah, there is other way also, but then you can do this, put the value of p in this quadratic equation, solve it once again. After solving the quadratic equation, one of the value will be 3, the other value will get. Question number 11 this was. Let's go to question number 12. Okay, the ratio of the roots of the quadratic equation are given, which is 2. So let alpha plus upon beta is equal to 2. So alpha is equal to 2 beta. Okay. Now see, alpha is already there in the problem. Huh? Alpha is already there in the problem. So let's take the roots as p and q. Okay. So p upon q is equal to 2. So the roots are not alpha and beta, the roots are p and q. Because alpha is already written in the problem. Okay. So p is equal to 2q. So x square plus alpha x plus alpha plus 2 is equal to 0. This is the quadratic equation. A is 1, B is alpha, C is equal to alpha plus 2. Okay. Sum of the roots P plus Q equal to minus B by, that is minus alpha. Right. Now P is equal to 2Q given in the problem. So 3Q is equal to minus alpha. Q is equal to minus alpha upon 3. Okay. P into Q. C by A. So that is alpha plus 2 upon 1. Okay. So Q is what? Minus alpha by 3. Okay. Or rather, first we'll write down the value of P. P is 2Q into Q is equal to alpha plus 2. Okay. 2Q into Q is alpha plus 2. So Q square is equal to alpha plus 2 upon 2. This 2 will cross multiply on the right hand side. Now Q is what? Minus alpha by 3. So minus alpha by 3 the whole square is equal to alpha plus 2 by 2. Okay. Now you simplify this. You can solve this further by opening the brackets, cross multiplication. Simplify this, you will get a quadratic equation. You can solve that particular quadratic equation and you may get the values of alpha. This was question number 12. Let's go to question number 13. Yeah. If R is the roots of the quadratic equation ax square plus bx plus c equal to 0, R is the ratio of the roots. Okay. So alpha upon beta is equal to R. So alpha is equal to beta R. Okay. Unlike previous problem, in this problem, alpha and beta is not mentioned in the quadratic equation. So we can take our roots as alpha and beta only. Okay. Yeah. So alpha plus beta is minus b by, the values are not given of a, b and c. Okay. So beta r plus beta is equal to minus b by a. So beta r plus 1 is equal to minus b by a. So beta is equal to minus b upon a into r plus 1. Alpha into beta is c by a. Now alpha is beta r into beta is equal to c by a. So beta square is equal to c by ar. Okay, beta into beta is beta square. Okay, now put the value of beta over here. Minus b a r plus 1 the whole square is equal to c by ar. Okay, squaring both the sides. No, sorry, it's already square on the left hand side. So a square upon a square r plus 1 is equal to c upon ar. Now there is a square on the left hand side and a on the right hand side. So one term will get cancelled. Cross multiply b square r is equal to c a r plus 1, and this is your required proof. Hence we have proved. Okay. Yeah. Let's go to question number 14. Find k so that one of the root of the quadratic equation exceeds the other by 2. Okay. So 2k x square minus 20x plus 21 is equal to 0. Right? So a is equal to 2k, b is equal to minus 20, c is equal to 21. Okay, and one condition is given, one root is more than the other by 2. So alpha minus beta is equal to 2. So alpha is equal to beta plus 2. Okay. Now what is alpha plus beta? Minus b by a. So minus b by a minus minus of minus 20, which is 20 upon 2k. Okay. So 10 upon k. Okay. Now put the value of alpha as beta plus 2. So beta plus 2 plus beta is equal to 10 by k. Beta upon beta plus 2. Beta plus 2 plus beta is equal to 10 upon k. So this will give me what? 2 beta plus 2 is equal to 10 by k. Take 2 common. Beta plus 1 is equal to 10 by k. Beta plus 1 is equal to 5 by k. Okay, beta plus 1 is equal to 5 by k. So beta is equal to 5 by k minus 1. We got the value of beta. Okay. Now alpha into beta is equal to c by a. Alpha into beta is equal to c by a. So alpha is equal to beta plus 2. That value we will substitute over here. Beta plus 2 into beta is equal to c by a. Now c by a, we can put the values of c and a as well. So c is 21 and a is 2k. So 21 upon 2k. 21 upon 2k. Now put the value of beta which we have calculated. The value of beta is 5 by k minus 1. Okay, so this is equal to 5 by k minus 1 plus 1. I'm putting the value of beta 5 by k minus 1. 21 by 2k minus 1 plus 2 is plus 1. So 5 by k plus 1, 5 by k minus 1 is equal to 21 upon 2k. Okay. So a plus b into a minus b, a square minus b square is equal to 21 upon 2k. Okay. Simplify this, take LCM, and then you may cross multiply and solve this further. First take LCM over here on the left hand side. Okay, after taking LCM, simplify and then cross multiply on both the sides, and then you may solve and get a value of k. You'll get a quadratic in terms of k. That you need to solve. Okay, let's go to question number 15. Question number 15. Okay, ax square plus bx plus c is equal to 0. One root is reciprocal of the other. So alpha is equal to 1 upon beta. Therefore, alpha into beta is equal to 1. Therefore, C upon A is equal to 1. Okay, because alpha into beta is C upon A. Okay, so this is the condition. Okay, now in this condition, A cannot be 0 because if you put A equal to 0 over here, so C upon 0 will be not defined, which is not the case. And here C is also not equal to 0 because 0 upon A should give you 0, but then we are getting 1. So A and C both are not equal to 0. This was the first sub question. Let us go to the second sub question. Okay. One root is the negative of the other. Alpha is equal to negative beta. So alpha plus beta is equal to 0. So minus b upon a is equal to 0. Okay. Right. So this is one of the condition. Here also a cannot be 0 because we got this condition minus b upon a equal to 0. So here a cannot be 0 because if a is 0, then this is going to be not defined. B upon 0, it will be not defined. Okay, but then we require 0 over there. Acha, but B can be 0 from this, and B has to be 0. Only if B is 0, then 0 upon A will be 0. So these are the two conditions. B is equal to 0 and A is not equal to 0. Third part, third part, alpha is equal to twice beta. Okay. Now alpha plus beta is equal to minus B by A. So 2 beta plus beta is equal to minus B by A. 3 beta is equal to minus B by A. So what is beta? Beta is equal to minus B upon 3A. Clear? Alpha into beta is C by A. So alpha is 2 beta. 2 beta into beta is C by A. Beta square is equal to C by 2A. Okay. Now what is beta? Beta is minus B by 3A the whole square. Okay. Is equal to C by 2A. So B square upon 9A square is equal to C by 2A. Okay. Now this A square and A will get cancelled. So 2B square is equal to 9AC. Cross multiply. 2B square is equal to 9AC. So this is what your solution is. Let's go to question number 16. Okay, 16 sub question 1. Find the condition that one of the roots may be unity. Okay, so alpha is equal to 1. Beta may or may not be equal to 1. Okay, so one of the root is unity, alpha is equal to 1. So alpha plus beta is minus b by a. So 1 plus beta is equal to minus b by a. Okay, so beta is minus b by a minus 1, which is equal to minus a minus b upon a minus. Okay, let us stop over here. Okay, so this is beta. Now alpha into beta is c by a. Okay, so alpha is equal to 1, beta is equal to c by a, but in beta value we know minus a minus b upon a is equal to c upon a. Okay, now take this negative terms on the right hand side. So 0 is equal to a plus b plus c. 0 is equal to a plus b plus c. Okay, that's the condition. Okay, we have a shortcut for this also, but then I have taken the long cut over here. That's not really very big a solution, but then fine. Yeah, let's go to question number 16, sub question 2. One of the roots may be 0. So alpha is equal to 0, but then beta may or may not be 0. Okay, so we don't know. So alpha plus beta is equal to minus b by a. So 0 plus beta is equal to minus b by a. So beta is equal to minus b by a. Okay, and alpha into beta is equal to c by a. Okay, now alpha is 0. So 0 into beta has to be 0. irrespective of the value of beta, beta का कोई भी value लेने दो. So 0 into beta is 0. So this is the condition. C upon A is equal to 0, correct? But then A cannot be equal to 0, because if A is equal to 0, then this is going to be maybe not defined. Okay, C will be not defined, correct? We require the value of C as 0. So for that, A cannot be 0. Third one, third one, exactly one of the roots may be 0. So only alpha is 0. Okay, in this, beta cannot be 0. Okay, so let's take this alpha into beta is C by. So 0 into beta is C by. So 0 is equal to C by. So this is one of the condition where A is not equal to 0. Okay, and C is equal to 0. Okay, now alpha plus beta is equal to minus B by. So 0 plus beta is equal to minus B by. So beta is equal to minus B by. Now guys, beta is non-zero. Beta is non-zero. So for beta to be non-zero, here B cannot be equal to 0. If B is equal to 0 in this, then beta will also be 0. Okay, so the conditions are this: C upon equal to 0, A not equal to 0, and B not equal to 0. These are the conditions. Okay, question number 4, as in the sub question 4, right? Both the roots are 0. So alpha equal to 0 and beta equal to 0. Alpha into beta is equal to C by. Now both are 0. C by. So C is equal to 0. Okay. A cannot be 0. Right? Because if A is 0, then C upon A, it can never be 0. C upon a non-zero value will only give you 0. So, so we can rather write this. The first condition is C upon A is equal to 0 and A cannot be 0. Because if A is 0, then this will be not defined. C upon A will be not defined, but then we don't require not defined, we require 0. Okay, then alpha plus beta is equal to minus B by. Now these are both 0. Minus B by is equal to 0. So minus B by is equal to 0. So B upon A is also equal to 0. Okay, this is the other condition. And here also obviously B is not equal to 0. Okay, correct. So that was question number 4. Let's go to question number 5. Let's go to question number 5. If the roots of the equation, one of the roots may be positive and the other is negative. Okay. Now alpha plus beta is minus b by. Okay. And alpha into beta is c by. So we'll analyze this particular condition. Okay. If suppose alpha is positive and beta is negative, one is positive and the other is negative, the answer plus into minus is negative only. How we will get minus from c by? When will be c by negative? When c is positive, a is negative, or c is negative, a is positive. See, because one of the root is positive, the other root is negative, the multiplication of positive into negative is negative. We require negative answer of c by. So c by a will be negative if one of the terms in c and a is negative and the other one is positive. So c is positive, a has to be negative, and vice versa. So the condition over here is C and A. C is positive then A is negative, or C is negative and A is positive. Okay. So let's go to question number 17. Okay, sub question 1. X square plus 2a plus 1 into x plus a square plus 2 is equal to 0. A is equal to 1, b is equal to 2a plus 1, c is equal to a square plus 2. Okay. Now one of the root is double the other. Alpha is equal to twice beta. Okay. This type of problems we have done earlier in the exercise also. Same exercise. Okay. So let's start with alpha plus beta. Alpha plus beta is minus b by a. Alpha is 2 beta. 2 beta plus beta is equal to minus b by a. So minus 2a plus 1. Okay. 3 beta is equal to minus 2a plus 1. So beta is equal to minus 2a plus 1 by 3. Okay. Now alpha into beta. C by alpha is equal to 2 beta. 2 beta into beta is c by. Let's check what the value of c and a is. C is alpha a square plus 2 and a is 1. So this is going to be a square plus 2. So beta square is equal to a square plus 1 upon 2. Now beta is this minus of 2a plus 1 upon 3. Okay, I'm putting the value of beta, but then this square will be there, a square plus 1 upon 2. Okay, now you can simplify this particular equation. You have the square on the left hand side, simplify it, take square on the left hand side. Okay, expand the bracket and cross multiply and get a quadratic possibly. Okay, from that you'll get a value of a. Okay, from that you'll get a value of a. Let's go to question number 2 of 17. 17 sub question 2. If k is one of the roots of the equation, okay, sorry, determine k if one of the roots of the equation is double the other. Uh, so alpha is equal to twice beta. First, I will write down this equation. K into x minus 1 the whole square is equal to 5x minus 7 x square minus 2x plus 1. Okay. So kx square minus 2kx. So kx square minus, okay, I'm just simplifying the equation. Fine. So kx square minus 2k plus 5 into x plus k plus 7 equal to 0. Okay. So we have got this particular format of ax square plus bx plus c is equal to 0. A is equal to k, b is equal to minus 2k plus 5, c is equal to k plus 7. Okay, these are the values of a, b, and c. Now, once you get the values of a, b, and c, look at the condition. Alpha is equal to twice beta. Okay, now start with alpha plus beta. Alpha plus beta is minus b by a. Alpha is equal to twice beta plus beta. So this is going to be 3 beta. Okay, I will put the values of b and a. B is minus of 2k plus 5. So b will be minus b will be the positive part of this 2k plus 5 upon a. A is k. So 2k plus 5 upon k. So beta is equal to 2k plus 5 upon 3k. Alpha into beta, c by alpha is equal to 2 beta C. C is K plus 7 and this is K. So K plus 7 upon K. So beta square K plus 7 upon 2K. These two got cross multiplied. Put the value of beta. 2K plus 5 upon 3K. The whole square is equal to K plus 7 upon 2K. Fine. So you can just solve this and get the answer. Solve this equation, you get the answer. Fine. Let us go to question number 3. X square minus 6x plus k equal to 0. A equal to 1, B is equal to minus 6 and C is equal to K. Okay. And the relation given over here is 2 alpha plus 3 beta is equal to 20. Okay. Now alpha plus beta is minus B by, so it is going to be 6. Now what you do is, this and this you solve simultaneously. Okay. So I'll multiply this with 2. 2 alpha plus 2 beta is equal to 12. Then I'll write this equation. 2 alpha plus 3 beta is equal to 20. I'll subtract this. So 2 alpha is gone. So this is minus beta, which is equal to minus 8. So beta is equal to 8. That you put it over here. Alpha plus 8 is equal to 6. So alpha is equal to minus 2. So we got the value of alpha, we got the value of beta. But then we are supposed to find out the value of k. Okay. Now x square minus 6x plus k is equal to 0. You either put the value of alpha or you put the value of beta in place of x. Because alpha and beta are the roots. Okay. Or you can also use the second condition. That is alpha into beta is cy. Now alpha is minus 2, beta is 8, c by c is k upon 1, which is k. So k is equal to minus 16. Okay. Let's go to the fourth sub question. So x square plus px plus 45 equal to 0. A is equal to 1, B is equal to P, C is equal to 45. Okay. Now given that square of the difference of the roots is 144. So square of what? The difference of the roots. So difference of the root is alpha minus beta. Square of this is equal to 144. So square this, alpha square plus beta square minus 2 alpha beta is equal to 144. Alpha plus beta the whole square is alpha square plus beta square is alpha plus beta the whole square minus 2 alpha beta minus 2 alpha beta is equal to 144. Now alpha plus beta is minus b by a, so that's minus b, and alpha beta, that is c by a, so 45 upon that is 45. So twice 45 minus twice 45 is equal to 144. So when you solve this, you will get two different values of p because this will be p square. Okay. Now once you get the value of p, the sum does not end over there. This value of p you will have to substitute over here. Okay, and once you substitute the value of p over here, and this will be two different quadratic equations because there are two different values of p. So put the first value of p in this quadratic equation, then solve it. Then put the second value of p in this quadratic equation and solve it. So this is how you have to proceed. So it doesn't end at the value of p. Okay. Let's go to question number 18. So 8x square minus 8x plus a is equal to 0. So a is equal to 8, b is equal to minus 6, and c is equal to a. Alpha is equal to beta square. It's given. Okay. So now alpha plus beta is equal to minus b by. See, I'm using the standard procedure. I'm not deviating from my procedure. There will be multiple ways to solve these problems, but then I'm not deviating. I'm keeping a very fixed procedure. So alpha plus beta is minus b by a. So beta square plus beta is minus b. So 6 upon 8. Okay, which is 3 upon 4. So 4 beta square plus 4 beta is equal to 3. So 4 beta square plus 4 beta minus 3 is equal to 0. Okay, so we require minus 12. So 2 beta plus 3 minus 1, 2 beta plus 3. So beta equal to half, or beta is equal to minus 3 by 2. So these are the two values of beta that we will get. Okay, right. But then we need to find out the value of a. Okay, so now alpha into beta is equal to c by a. Okay, alpha is beta square. So beta cube is equal to c by a. Now c is a and a is 8. So a upon 8. Right? Now there are two cases over here. Case 1. Put beta equal to half. Put beta equal to half here and calculate the value of a. Case 2. Put beta equal to minus 3 by 2. Put beta equal to minus 3 by 2 here and get the value of a. That's how we have to solve and get the value of a. We will start with question number 19. Okay, now there are two quadratic equations. The quadratic equation number one is ax square plus bx plus c equal to 0. And the other quadratic equation is a dash x square b dash x plus c dash x is equal to c dash is equal to 0. Now the roots are reciprocals of each other. So the roots of this are alpha and beta, and the roots of this are 1 upon alpha and 1 upon beta. The roots are reciprocals of each other. Okay, they are having reciprocal roots means if alpha and beta are the roots of the first quadratic equation, the roots of the second quadratic equation will be 1 upon alpha and 1 upon beta. Okay, now see how to solve. Alpha into beta is c by product of the roots. Okay, in the second quadratic equation, the product of the roots is equal to c dash upon a dash. Product of the roots is multiplication of this two, and it's c by a. So in this equation, it will be c dash by a dash. Okay, so 1 upon alpha beta is equal to c dash by a dash. Now put the value of alpha beta. Alpha beta is c by a. So 1 upon alpha beta will be a by c. A by c is equal to c dash by a dash. Okay, this is the first condition. Okay, mark this. Now second condition. Alpha plus beta is minus b by a. This is as per the roots of the first quadratic equation. Alpha plus beta is minus b by a. Okay. Second quadratic equation has roots 1 upon alpha plus and 1 upon beta. So sum of these roots will be minus b dash upon a dash, because in the second quadratic equation a b c are a dash b dash c dash. Okay. Now here you take LCM. Alpha plus beta upon alpha beta is equal to minus b dash upon a dash. Okay, minus b dash upon a dash. Now alpha plus beta is minus b by a, and alpha beta from the previous page it is c by a, minus b dash upon a dash. A getting cancelled, negative sign gets cancelled. Okay, so b upon c is equal to b dash upon a dash. So this is condition number 2. That's how we end this particular problem. We'll continue with question number 23 and 24. Okay, so let's go to question number 23. Yeah, x square is equal to 7x plus 4. Okay, and we need to prove that alpha cube is equal to 53 alpha plus 28. Alpha and beta are the roots of this equation. So x square minus 7x minus 4 is equal to 0. Okay, now see, since alpha is one of the root of this and first part of the proof, we are supposed to put alpha cube is equal to 53 alpha plus 28. So since alpha is one of the root of this equation, we'll put alpha over here as x or x as alpha. Okay. So alpha square is equal to 7 alpha plus 4. Okay. Now we'll box this. Now I'll multiply with alpha on both the sides because we require alpha cube. So multiply both the sides with alpha. So this will be alpha cube 7 alpha square plus 4 alpha. Now this part alpha square. Alpha square you put 7 alpha plus 4. Okay. So this is equal to 7 sevens are 49 alpha plus 28 plus 4 alpha. So this will give you 53 alpha plus 28. So that is how you need to prove the first part. Second part is very simple. You can do it on your own. Question number 24. Question number 24. Okay. Yeah. So x square plus px plus 1 minus p equal to 0. Okay. Now 1 minus p is one of the root. 1 minus p is one of the root of this equation. So put x as 1 of 1 minus p. Since 1 minus p is one of the root, we have the full liberty of putting x as 1 minus p. So put x as 1 minus p. So p into 1 minus p plus 1 minus p into 0. Take 1 minus p common. I'm taking 1 minus p common. So 1 minus p plus 1 is equal to 0. This is gone. So 2 into 1 minus p equal to 0. So p equal to 1. Okay. Now once we get the value of p, it is not the end of the problem. We have to put this value of p over here and here. Okay. So x square plus p into x, that is x, and 1 minus p, 1 minus 1, which is 0. Okay, so x square plus x is equal to 0, x into x plus 1 is equal to 0, so x is equal to 0 or x is equal to minus 1. Those are the roots. Fine.